Hello everybody. In this video I'm going to be solving the last problem number 25 from the 2017 F equals ma test. So we have a planet P orbiting around a star S as shown in the figure. So this is an elliptical orbit with one foci or focus on S. The semi-major axis of the orbit is A, so that's here. So this is the center of the ellipse here. And the perigee, so the perigee here, the distance, the shortest distance from sort of the planet and the star is 1/2 a. So this here is 0.5 a. And so now the question is, um, when the planet, basically when the planet passes on the point P directly above the star, or in this figure, directly above, um, its speed is v1, and we want to know what is its speed v2 when it's passing at its closest point to the star. And basically we want to find its relationship to v1. So the thing that we're going to be using here is um, conservation of angular momentum, right? So angular momentum is the position vector crossed with momentum. And here our position vectors, this is conservation of angular momentum with respect to the star. So our position is with respect to the star. Then this value of L stays the same no matter what R is. Momentum, normal momentum is just the mass times velocity. And since we're just dealing with a planet here, of just some random mass m, it's not going to really matter. So we can just ignore the m in our calculations, or we can say m is equal to 1 or whatever. Uh, Likewise, since none of these answers really depend on a, I'm just going to assume a is equal to 1 to sort of simplify things. So we have that this distance is 1/2, and here I'm going to draw in the second focus of the ellipse here, which I'll call F, because we want to find out more information about um, sort of these positions. Because if we know our position vectors, then we can easily relate the velocity here to the velocity here, because we know that this position crossed with the velocity is equal to this position crossed with the velocity. Uh, and so in our case, we see that here the position crossed with velocity is just 1/2 v2. So we just need to figure out what our what our position here is, and then we need to cross it with the velocity. So the first thing I'm going to do is to figure out, actually I'm not going to do that first. So what we want to do is figure out what the semi-minor axis is. So that would be this length. We want to find out what this length is. To do that, we can draw lines from this point to both of the foci. So I'll call this some point C. And we know that um, the sum of distances in an ellipse is a constant. And specifically, that constant is the major axis, which in our case is the length 2. So these two lengths add up to 2, but as we can see, they're both equal. So in fact, these are just both 1. Now we know this length here is 1/2, because this is 1/2 and this is 1/2. And so that makes this length here square root of 3 over 2. And so now we want to find out what this length is from the length of P to the star, because that will give us our position, R. Um, so to figure that out, we can just apply the same tactic, right? Draw lines from P to both of the foci. And again, we know that they add up to 2, and so we can create an equation using Pythagoras. So here I'm just going to redraw this. Um, this is P, this is S, and this is F. We know that this length from S to F is 1 because it's 1/2 plus 1/2. And here I'm just going to denote this length PS by X, and this is 2 minus X because, like I said, these two lengths have to add up to 2. Now, if we use the Pythagorean theorem, I believe, beautifully enough, this ends up being a 3, 4, 5 triangle. But I mean, you can only show that doing algebra. But so x is equal to 3 over 4. Now, of course, this doesn't have any value. It's just kind of cool. Um, so we know that this length is 3/4. So now, if we're crossing this position, right, this position is completely vertical. So we need to know the horizontal component of velocity. So here, if I draw, we have v1. We want to know its horizontal its horizontal component so that we can multiply by the uh, by our position, right? Because if we're doing a cross product, then we have to multiply perpendicular lengths. That's why I was able to just take 1/2 v2 here, because the 1/2 and the v2 were perpendicular. So this will be 3/4 times the x component of v1. So perhaps we can get some leverage uh, on the sort of ratios, right? Some trigonometric ratios here. Well, as we notice, the velocity is going to be tangent. The velocity at any point is obviously tangent to the orbit, right? So if we set up an equation, we can use calculus to derive what this slope would be, because the slope of v2 would necessarily be the derivative of the ellipse at that point. And we know what that point is, right? Because we know its coordinates. It's negative 1/2. If we call this the origin, it's negative 1/2 3/4. So we can just figure out what the derivative of the ellipse is at that point. Now, I will note here that the F equals MA exam is designed to be just a regular high school physics exam, and no calculus is necessary, but and there is a way to solve this problem just without using any calculus, obviously. But this is the approach I used, so that's what I'm going to do. So if we model this using an equation, we see that x squared, we get x squared plus y squared times 4 over 3 is equal to 1. This is the equation of our ellipse here, just using um, the lengths of the semi-major and semi-minor axes. And so we can use implicit differentiation to get 2x plus 8/3 y times the derivative of y is equal to 0, which implies that the derivative of the change, or the slope of the ellipse at any point xy is going to be equal to negative 3/4 x over y. So now here we have our point xy, which is negative 1/2, comma 3/4. So in particular, y is equal to 3/4, so that just cancels out with this 3/4, and we're left with dy dx is equal to negative negative 1/2, which is just 1/2. In particular, that means that v1x is twice v1y. And so by Pythagoras, that means that v1x is equal to 2 divided by square root of 5 v1. Because if this were a 2 and this were a 1, then this would be a square root of 5. So here we can finally return to this, this original equation, and we can get rid of the 1/2. So we get v2 is equal to 3/2 times 2 over square root of 5 v1. And so our final answer is just 3 divided by square root of 5 v1. And that would be answer choice A as our final answer. So anyway, I hope you enjoyed this solution, and thank you for watching, and I'll see you in my other videos.